Hi, today I'd like to describe how to approach a problem of detecting cycles in a linked list of nodes. So let's imagine a linked list. It is the structure where each element has a limited knowledge and can refer only and has limited knowledge, so it has only a pointer to the next element. So it is the right one directional linked list because each element points to his right hand neighbor. This structure, that kind of structure, has one big advantage. It's very fast in terms of insertion and in terms of removal of elements. This can shrink and grow dynamically during runtime, and is very efficient in terms of extension or removal of elements. Because if we want, for example, remove an element from this list, we just change the pointer in the preceding element. So after removing element of 3, we just change the pointer for 2 to point to the 4. In general, we could possibly assume that in implementation of node, we would have a property called next, which contains an information about the next element. So for the first element, the next property would have point to the second one. For the second element, next property could point to the third, and for the third element, the next property could point to the fourth, and so on. Okay, so let's imagine a situation when someone is delivering us a very long linked list of nodes of elements. This is the information that we want to pass for later processing. We expect that we get them correct, but sometimes might happen that such a list will contain a cycle inside, which we consider as an error, and we want to report it to the customer that it's bad, and we are refusing later processing for this list. So cycle happens when the definition of cycle in list of nodes might be like that. The cycle appears when at least one element is referred 2 times or more. Yeah? So we clearly see that the third element is referred from the second one and from the fifth as well. This is the situation we don't want. We want to detect if there is a cycle in a linked list. So we could approach this problem using a storage. It requires just one iteration, and if we iterate over the list every time we hit element, we check if it is not marked as visited in our visited structure. It might be, for example, a set or a hash set. So for the first element it is empty, so we just put it to our visited structure. We go to the second one, we see that the second is not here, so we add it. The same we do for 3, 4 and 5. 3, 4 and 5. And iterating from the fifth to 3, we see that 3 is already there. So that means that we have a cycle. So this approach is fast, but the problem is, of course, if we use proper structure here. But the problem is that we can't use it for our purpose because it requires too much storage. Let's imagine we have 1 million of element, and the very last element in the list points to somewhere in the middle. If that's the case, we could add up with a structure of visited element which will be equal in a size with our linked list. We don't want that. We want to approach this problem in different way. One of the smartest way to solve this problem without using storage is to iterate over this collection at two different speeds. So for example, let's draw an iteration at speed of 1. So for one iteration we go from the just by one node. So being on the node number 1, we refer to the next of 1. Being on node number 2, we refer to the next of 2. Yeah? And being on the node of 3, we refer to the next of 3, which is 4. Yeah? So in parallel, we could launch an iteration at the speed of 2. So we travel 2 nodes per one step, per one iteration. So starting from the node 1, we jump immediately to node 3 because we are referring to the next of 1. Being on node 3, we jump immediately to node number 5 because we refer to the next of number 3. So we clearly see that we iterate at two different speeds. We launch this iteration and see what will happen. Let's write down where we will be in each step. So iterating with the speed of 1. We are first on the first node, and for the speed 2 we are also on the first node. We do next step on the traveling with the speed of 1, we are on the 2, traveling with the speed of 2, we are on the 3rd, traveling with the speed of 1, we are on the 3, traveling with the speed of 2, we will be at 5, traveling with the speed of 1, we will be at 4, traveling with the speed of 2, we will be at 4. Yeah? Which means that those elements are equal. If they are equal, with our two heads, we are using two iterators, we are using to iterate over this list at two different speeds are equal, it means that we have a cycle, so we can report it as an error to our customer. We didn't use any storage for that, so this is the main advantage of this solution. Okay, so you can find the implementation of this very simple algorithm in the link to my GitHub repository below. If you have any ideas how to solve this problem in a different way, please put it in a comment. Of course, during a real program we should check whether we have next implemented, whether it is not null or empty, but for the better understanding we assume we are not doing that. Thank you.